everything good today. And then on Wednesday and Thursday, Wednesday, you're going to have a little bit of an online review of right triangle trigonometry. And then on Thursday, we'll talk about that and special right triangles. And that'll take us into spring break, basically. So, all right. Let's see what we got here. Let me take attendance. Close this month. Well, I want to hear about your weekends real fast, too. You had fun this weekend, hopefully. That row's here. Andrew's out again? What? Okay. Submit. Submit. Boop, boop, boop. Submit. Okay. Yes. All right. Let's see what happened. Dylan, what'd you do this weekend? It was fun. Damiano, Yano.
Weekend. Yes, weekend.
Was it good?
Yes.
All right. We could just go thumbs up or thumbs down.
Yeah, it was good.
It was good. Alexandria.
It was good.
It was good. Yes, Kevin.
Good.
Yes. Rogers.
It was okay.
Uh-oh. You were this or this, you were this. Slope of 0. All righty. Ready. Yeah. He got a thumbs up. Broxma. It was okay. Do you still have the mutts? The dog? No? Okay. That's good.
It
It was
was good.
good. Woo. Yes.
Good.
Double thumbs up. Whoa.
Good.
Were you sick this weekend still?
I was not.
Good. Glad to hear it. And Geiger's got a thumbs up. True? It was fine. That's a thumbs sideways. Thumbs up and ooh, down. Okay, sorry. All righty. Great. Sequences series. So, how are we doing on these guys? Are we doing good? Are we feeling like we're understanding the like this first page is just like basic concepts. Are there problems here that we're struggling with on the first page? I guess that's the first page, yeah.
On number 9,
Number
it
9.
says, which one is it and how do you know? How did you want us to explain it?
The following two terms of things are given to you. You're asked to decide if the sum of the first 21 terms will be bigger if it's arithmetic or geometric. So you have to find both an arithmetic sequence for this and a geometric sequence, and then find the 21st partial sum for both of those to see which one's bigger.
Okay, so you just have to say which one is bigger, not how do you know? Like,
Well, yeah, I mean, how do you know would be showing you the numbers. In other words,
okay.
if I had a quiz or a test, you just said this one's bigger and there's no supporting work, it'd be like, okay, well, that's not going to give you credit for that. So yeah, how you know is just showing you the values you got for those terms, so those sums.
All right.
All right. Well, let's look at some of these. Write a rule for the sequence. I think you guys should give me answers again. I like when you guys give me some answers. Number 1. First of all, is that arithmetic or geometrico? It's arithmetic. I'll do this one. -2 plus then minus 1 times 9. There you go. Boom, bam, slam, done. Okay, number 2. We're supposed to be find the 12th partial sum of the sequence in number 1. So here's the deal. When you take the test, if I ask for something like this, okay, you can do it like this. And you could, like on this one, if you wanted to, you could use the rule 12 times -2 plus. I'd have to find the 12th term in here, which is 97. I can do it that way, all right? Or I could do what? Write it in sigma notation. If I was going to do this in sigma notation, I would want you to write that down. And you would write n equals 1, 2, what? What goes up here? 12. So this is saying add the first term through the 12th term, and then what goes here? It's the what? It is the rule for the nth term. So here you just put -2 plus n minus 1 times 9. Again, if you want to simplify that, you can, or you can leave it like that. Doesn't matter which way you do it, you better get the same answer. What is the sum of the first 12 terms in that sequento? 570. There you go. Okay. Number 3. Need a rule. A sub n equals, again, you don't have to use the first term on the arithmetic. I could use this one right here. Okay. So it'd be 23 plus, but what's going to be in here? N minus 5. Perfect. All I need to know is what the common difference is, and that's like finding the slope. What is the common difference? -6. Boom. Done. If you want to simplify it, can you? Sure. Doesn't matter to me. Okay. Number 4. This given this. So here you'd have to go ahead and find the rule. Either way, you have to find the rule on this one. So let's get the rule to start on number 4. Okay, so it's -8 plus or minus, or plus n minus 1. That ain't the common difference. So what is it? What's the common difference? Oh, this one you don't have to. My bad. I was nice. I gave you the 43rd term. You could just do this one. This would be quicker to just do this. 43 times -8 plus 140 all over 2. It'd be easier to just plug that one in because I gave you the first and 43rd term. Okay? So what do you get here? 43 times. Yeah, when you get this in here, 140 minus 8 is 132 divided by 2 is 66. So it's 66 times 43, whatever that gives you. Yeah, Geiger. Love it. 5. If a geometric sequence has a rule of blah, 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 what does the 2 represent as well as the -3? What is the 2? 2 is a sub 1, or you could say it's the first term. Either way you'd want to say it, okay? And then what's -3? -3 is r. It's the common ratio. You could either say it or you could say it's r. 6, write a rule for this sequence. This one's geometric. What's the common ratio? -3 to the n minus 1. Boom. And then 7, you're using number 6, and you're going to find the 12th partial sum. So I'm just going to write it like this. 1 to 12 of -3 times -3 to the n minus 1. And then that's just, it's so much easier to do it that way, guys, for you, especially for the geometric. All right. What do we get? Who's got it? Dylan Damianiano? You got this one, number 7?
Yes.
What do you got?
-3,985.
-3,985?
Yes. 1 after 8 out and 5.
It's not a whole number? It should be a whole number.
I got 398,580.
It should be a whole number.
Yeah.
Did you do, Dylan, did you do it this way or did you do it on using the other rule? That's, yeah, more dangerous than the geometric. Try it with the graphing calculator instead. You gotta do it with sigma. Just do it that way, see what you get instead. Number 2, x is 1 to 12. Raised to x minus 1. 398,580.
Yeah.
Boom. Yeah. All right. Number 8. I've given you the 6th term. I want the nth term. You need the first term. So this is, the rule is this. So plug in what you know. What do you know? You know a sub n is what? Negative 486 equals the first term times what? Negative 3 raised to the 6 minus 1, which is 5. So a sub 1 is literally negative 486 divided by whatever negative 3 to the 5th power is. That's all it is. And I know it's going to give you back a positive number, because it's a negative over a negative. Ty, what'd you get back for that?
I got 2. It's a
2? Yes? 2, yeah. So then my rule would be a sub n equals 2 times negative 3 to the n minus 1. All right. Woo! 9. Okay, so now I have to do 2. We got an arithmetic and a geometric. All right, if this is arithmetic, okay, let's write our rule for this to start. A sub n equals, I'm just going to use this one right here, 4 plus n minus 2 times the common difference. And the common difference here is going to be negative, is it negative something? Negative 12, isn't it? Yeah, it's negative 12. Because here you're going to get negative 30, you're going to get negative 36 divided by 3. It's negative 12. Okay, great. There it is. Geometric. All right, now here, what do I know on the geometric? From here to here is 3 r's. So it's going to be r cubed equals negative 32 over 4. So r cubed is negative 8, which means r is equal to negative 2. I need that. Right? Now, that means to go from a term to the next one, I'm going to multiply by negative 2. That means to go the opposite direction, I would do what? Divide by negative 2. So I can find the first term. If a sub 2 is 4, to go this direction, it's times negative 2. That means to go this direction, I would divide by negative 2. So that means the first term is what? Negative 2. I mean, there's lots of ways of doing these, thinking through. So now my rule here then is a sub n equals negative 2 times negative 2 to the n minus 1. All right? All righty, here we go. So, what do we get for this guy right here? Arithmetic. I'll tell you what, I just feel like doing that. X, whoopsie, get out of there. Number 2. X, 1, 2, 21 of 4 plus the quantity of x minus 2 quantity times negative 12. Okay, so see if you guys agree. You get this for this one? Yes? That's just doing it using the calculator, or Desmos. You should get that if you're using summation notation. And let's do, what is wrong with my, okay, here we go. X is 1, 2, 21 of negative 2 times negative 2 raised to the x minus 1. Here I get negative 1398102. Wow, you guys agree with that? Mm-hmm. Yes? So these are my 2 answers. So which one of these deserves to have the blue star for being the what? Bigger one. Which one's bigger? terms, right? Now, why would I even ask this question? This is all about making people do what? Remember that on negative numbers, the closer you are to 0, the bigger the number is. Because some people might just look at this and say, oh, well, that's a million's a lot bigger than 1,000, but you're talking negatives, right? It's kind of a trick in a way. Kind of a trick. Just making sure you guys are paying attention. Okay, anything on the first page you want to ask about before, since we just did it? All righty, here we go. So let's just give some answers to these. I'm not going to work them out unless we need to. Who wants to give me the answer to number 1, the number of seats in the phi tab? Okay, Geiger, you have your hand up first for this one. 2,340. Okay, number 2, a rule to start. Am I going to have to do number 2? Who's going to want me to do number 2? Anybody's going to want me to do number 2? You have a rule? What do you have?
A of n equals 6 to the n minus 1.
Okay. All right. You have anything different for that one? What do you have?
I had something different for number 1. Yes.
You have something different for number 1?
Yeah.
Oh, what did you have for number 1?
I had 2,460.
We'll have to check those. We'll see. We'll come back and let's just do it now. Why not? Here we go. Auditorium has 20 seats on the first row, 24 on the second, 28. So it's going up by 4. This is a D is 4. So it looks like A sub n is 20 plus n minus 1 times 4. And I'm asked to find the sum of rows 1 through 30 of this rule right here. Okay, let's do that. Whoop, whoop, whoop. X1 through 30 of 20 plus 20 of x minus 1. Okay, is everybody doing it? Oh. So does anybody, once you, I've got an answer in front of me, I'm just kind of curious if you guys are doing what you're getting.
Both times I've done it, I got
Both times you got what?
2,440.
So you got this one?
Twice.
Twice. Okay, anybody else get that one? Right, I know you did, Kyrie, you gave it to me. Kevin, you got it too? Alexander, did you get that one too? Did you?
Yeah.
You got that one too? Anybody else get that one? I'm kind of curious. Ryan, when you did it, did you use sigma on yours?
Not the first time. The first time I did it like the regular.
So you found the 30th term and did it that way?
And then I did the sigma and I got the sigma.
Okay. And when you did the sigma, did you use this rule or did you simplify? I'm just curious.
I use that.
Okay. What did you get?
I got the same thing.
Well, I mean, you got this again?
Yeah.
So which way are you doing?
Sigma.
Just curious. Why were you doing different? You have yours. Oh, you used Desmos for yours?
I did 24 plus. Is that what
20 seats in the first row. That's why. That's why. Okay. Yeah. This is the one you guys are saying. This is it right here. Yeah. That's a simple. That's okay. A little simple mistake there. Okay. All right. Number 2. Let's just go ahead and read this one. Domestic bees make their honeycomb by starting with a single hexagonal cell, then forming ring after ring of hexagonal cells around the initial cell as shown. The number of cells in successive rings form an arithmetic sequence. It says, write a rule for the number of cells in the nth ring, okay? So the number of rings is like the term, right? So this, is this really even used per se? It's not, okay? So the first term, when you have one ring, it's what? 6. I'm just going to write these numbers down. So this is like a sub 1. it's 6. This 2 rings, a sub 2, how many total do you have now? Or how many are in, I should say, ring 2, not total. 12. Right? Now, it tells you that it's what? They want you to write it like it's an arithmetic. So they want you to view it as what? You're going to add 6 every time. Because if they didn't tell you it was arithmetic, you could say, well, I thought it was geometric and the next one was going to have 24. Okay? But they're telling you it's arithmetic. So that means that from here to here, that D is plus 6. Okay? So rule for the number of cells in the nth ring. So that would be a sub n equals 6 plus n minus 1 times 6. And that's what you said, right? Is that what you said?
No, I did. I forgot it was arithmetic.
Oh, okay. Then it says, what is the total number of cells in the honeycomb after the 9th ring is formed? Hint, do not forget to count the initial cell. I'm going to worry about that at the very, very end. Okay, at the very end, I'm going to find what? The series of how many rings? 9. So I'm going to find this. N equals 1 to 9. Okay? Of this, 6 plus n minus 1 times 6. And then to that, I'm going to do what at the very, this is going to be one thing. And what am I going to do at the very end? Add 1 to that. Because this is the initial cell you started with. All right? So how many total honeycomb? That makes me want to have a big bowl of honeycomb cereal right now. Oh, I would love that. Honeycomb, honeycomb. 9 of 6. So what do you get in here? What does this give you? 270. So it's 270 plus 1, so it's 271. Okay, 271. All right. Woo-hoo. Any questions on that one? Yeah, Kristen.
When you're putting like one of them in my notation into like
Yeah.
you're not putting anything in for the and my
Just this entire thing to know that it's finding the sum of all of them. That's the, and then yeah. So now it's there. Yeah. Mm-hmm. Yep.
Show me that, dude. What has to do?
This. When you do this on Desmos, this has to be in parentheses because it needs to know what is it finding the sum of. What rule is it finding the sum of? So you have to put it in parentheses so it knows. All right, good. Number 3. Suppose you go to work for a company that pays 1 penny on the first day, 2 cents in the second, yada, yada, yada. It says, what will your total income be for working 31 days? My first question is it arithmetic or geometric? It's geometric, okay. All righty. And then, is this a sequence where you're finding an nth term, or is it a series? This is a series. So you're literally finding S sub 31 is what you'd be finding. Or you could say you're finding this, n equals 1 to 31 of, what is the rule for this now? Let's think about it. On the first day, you get a penny. That's the initial amount, right? That's term number 1. How do you write a penny if it's money? 0.01. And then what happens? You're going to take that number and double it. So there would be a rule. And again, on Desmos, put this in parentheses. Okay? So what is the total income for the 31 days? Would you take this job, I guess, is the question, for 31 days? X, 1, 2, 31 of 0.01 times 2 raised to the x minus 1. Would you take this job? Yes or no? How many of you would take this job? I would.
Yeah.
My goodness, heck yeah, I'd take this job. If I took this job, would I be working again, you think? No. Because how much would you pay? Yeah, $21,474,000, 836 and 47 cents. I'll give you guys the 47 cents. I'll just tell them, hey, you know what? Round it to the nearest dollar. I'm fine with that. What's that?
But the tax, you know, there's so much of that for tax.
Yeah, it's true. Not enough. I'd still be able to retire. I mean, even if I gave 50% away in taxes, I'd have $11 million roughly. I think I could live on that for the rest of my life. Okay. Beautiful, 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 beautiful. 4. First year toy manufacturer introduces the new toys at sales total 49. Okay, boom. The company expects its sales to drop 10% each succeeding year. Find the total expected sales in the first 6 years. Total. That means it's a series. It's a total. Not how much will they sell in the 6th year, but the total expected. Now, if it drops 10%, what's it going to retain? If it drops, it keeps what? Keeps 90%. That's my R value then. It's 0.9. Okay, 1 minus R. 1 minus 0.10 is 0.9. So let's do this. What do I know? A sub n would be equal to what? I'm just going to write my rule to start. 495, comma 000 times 0.9 to the n minus 1. I want to find n equals 1, 2, 6 of that rule right there. So what would they expect their total sales to be? Let's see here. Okay, I got $2,319,367.05. You guys agree with that?
Yeah.
Hopefully. Is that a lot quicker than doing that the other way with the rule? Yeah, it is. And I want you to do that. Especially in the word problem. There's no reason not to. Okay? Bless you.
Thank you.
Okay, any questions on this page? Yeah.
I got, when I did it, I got my R.
For number 4? Well,
So how do you,
because if you're losing 10%, that means it's this. To drop 10% means it's 100% minus 10%. That's the 1 minus. This is always going to be 1 plus or minus R because it's exponential. This is decay. It's 1 minus 0.1, which is 0.9. Because remember, you're not trying to find out how much is it losing. You're trying to say, hey, what can I multiply this by to get the new amount? If I multiply it by 0.10, I then have to take that and subtract it from 495. So I know if I'm losing 10, I keep 90. So if I just multiply this by 90%, I'll get my new value every time. All right? Woo! All righty. Oh, the old deer population is increasing. Yes, it is. This year, the population was 1.025 times last year's population of 2537. it's going to increase at the same rate for the next few years. Write an explicit formula. That's just write in the formula, guys. Okay, don't get all crazy. For the sequence, where n is the number of years since the population was 2537. So this is basically your first term. So this would just be what? A sub n equals 2537 times 1.025 raised to the n minus 1. Boom, done. Find the population for the 10th year. So now we'd be finding, and oh, what? Nope, we're finding what? A sub 10, not the whole population. Yeah, find this. So what do we get for the 10th year? It's just 2537 times 1.025 raised to the 9th power. 2537 times 1.025 raised to the 9th power. Now, of course, we have to round this because you can't have a partial deer. We're not counting that one that's just being born or anything like that. So it's about what? 3,168 deer. We're just rounding it there. All right. Number 6, logs are stacked in a pile, 24 and 15 on the top row. There are 10 rows in all, with each row having one more log than the one above it. Okay. How many logs are in the stack? So think about what I've given you. Stack, so 24 logs on the bottom. So this would be like, I could call that a sub 1 is 24. 15 on the top, and there are 10 rows. That's telling you that a sub 10 is 15. That's all. I mean, I'm telling you that information there, right? Great. All right. And it says how many logs are in the stack. Well, guess what? Do I even need to do a rule for this one? This would be an easier one to do what? This would be an easier one to do S sub what? I'm finding the sum of all 10 rows, right? So what am I going to do? 10 times 24 plus 15 over 2. I mean, I can just do this one without even writing a rule. Now, so sometimes sigma notation is great. But this one here, if I give you the first and the last term for an arithmetic, then you want to do what? It's best to just do it by using this rule. It's really quick then. Okay? It'd be pretty darn quick to do it this way. So how many logs total do I have? Is it 195?
Yeah.
Yeah, I just did that in my head. Woo! Number 7, ball is dropped from a height of 16 feet. Each time it drops, it rebounds 80% of the height. It doesn't lose, it keeps 80% of the previous height from which it was falling. Find the total distance traveled in 15 bounces. Ooh. Total distance is a series. Okay, so I know this is going to be a series question here. This is telling me it's a series. Arithmetic or geometric? Well, if it's a percent, that's multiplication. That's got to be a what? Geometric. This right here is R. R is 0.8. That's what it's keeping. It's keeping 80%. So my initial one here. Ooh, boy, this is tough. So here we go. Is it going to be 16? So A sub n, because it's going to drop down 16 feet, and then it's going to go up, right? And then it's going to drop. It's not going to go as high. It can't. Physics says it can't, right? Science says it can't go as high. We know it can't. It's just being dropped. So A sub n equals 16 times 0.8 to the n minus 1. So I'm going to find the sum of that now. So n equals 1 to 15 bounces. Is that right?
Yes.
Okay. Now I got to be really careful on this. I'm not going to go any further than this. All righty? I want to draw a little picture. How many of you did it like this, by the way? Just raise your hand. You didn't? Oh, but how many of you thought through and just were approaching it like I am? Maybe you did a different version of it, but you did this idea, right? All right, I want everyone to think about this. So I'm going to come over here. So here is the ground, let's just say. And here is the ball, and it's 16 feet above the ground. So here's where it's starting at, right here. So this distance right here is 16 feet. Okay, so now what's going to happen? I'm going to drop it. And it's going to go like this, and it's going to hit. Now we know it goes back up 80% of that. What is 80% of 16? Huh? 12.8, okay? So that ball is going to, now here's you got to be careful. The ball is going to come up to right here, and that was 12.8, and then it's going to do what? Drop down 12.8 again, isn't it? I just heard him go, oh. I have to be careful on this, don't I? I got to think this one through a little bit more. It's not just a regular series. That 16 happens how many times? The 16 happens once, but everything else is happening twice. Oh, that's not cool. So let's rethink this a little bit. It is a series, okay? I'm not going to rethink it. I want you to rethink it before we go any further with it, because we're almost out. So think about that. If you didn't do that, which I'm guessing maybe a lot of you didn't do that, how am I going to get through this problem now? Having put that on the board over there. You guys try that. Oh my goodness! Must be an order for Dominique Alanigo's pizza. You guys are about over, right? Yeah. Room 333, Mr. Snyder. Yep. Yep. Bum, 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 bum. Do, 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 do. Oh, well, probably could just. Stacy,
What's that?
there you go. Room 237.
Okay, thank you.
Yep. Oh, yeah. Oh, yeah, oh, yeah, oh, yeah.
Are you gonna post these on Google Classroom?
What's that?
Are you gonna post this packet on Classroom?
I can. Oh, you mean the answers to this? I can, yeah. Yeah, I'm sorry. I'll also post, we're doing some extra problems after this, just in class. So what I'll do is I'll post them online, the answers, and then you can just see how, like, you can look at them and see if you understand what happened in them, okay?
Good. Yeah.
have you thought about how we're going to do this? You want me to erase anything, add anything? What do you think? Do I want to include that 16? No, not right now, I don't. So I'm going to actually change that. Okay, so what do I want to, how am I going to do this? What do I want to put here then? Want me to make it 12 point?
8.
Okay, so that's the first, that's the height it goes, that's the distance it travels on the first bounce. So that 16 is not even a bounce, is it? That 16 is the original drop height. That's kind of like that's before that. Okay, so if I'm going to find now the distance traveled in 15 bounces, see if you guys agree with this. Would it just be n equals 1, 15 of 12.8 times 0.8 to the n minus 1 times 2 plus 16? Yeah.
Wouldn't it be 14? Oh.
That's why what do you guys think? So, is this the first bounce? This is one of those that's kind of like, what do you consider the first bounce to be, I guess, right? What do you consider the first bounce to be? Is the bounce, like, is that red dotted line a bounce? Yeah, it did. It did hit the ground, I agree. Okay, so is that one of the 15 though? Where are the bounces really occurring at? Is this where the bounce is right here? Is the bounce the contact it makes here? And I'm not saying there's a right or a wrong. You understand what I'm saying here to you? This is all about interpretation of that. Okay? How do you interpret what it means by where the bounce is? Do we consider the initial drop a bounce? That's part of the question. And this question's there more than anything to get you guys talking and thinking. Because two people could read this and kind of go, well, I thought that first one was not even part of the bounce, it was just a drop. And then it bounced 15 times after that. Maybe they only considered the blues, if I kept doing all the blues, maybe they considered the blues the only part that were important on this. Because those are the only heights that occur after it did what? Actually hit the ground and bounced. I don't know. I'm just saying to you, this is one of those that, first of all, I wouldn't give this to you on a test as far as everybody said the same answer. This is one of those questions that I like to generate discussion. Because it's not just cut and dry. There's thought, you need to give a thought behind what you're doing. So if I do this, if I did this right here, let's think about it, then I'm saying that there's 15 bounces and this is not considered a bounce. But if it's not considered a bounce, should I even include it? No. That's why this is here to talk about it. So if I did this, would this be the distance traveled in 15 bounces if I'm just considering the blue dots over there? Yes. Would I have to multiply by 2? Yes. Yes? Because I'd want up and down both. Again, this is one of those, it's all about getting you to think. The first thing is realizing that for every bounce, it's got 2 different of the same length, right? But here's the question. When this goes down, does it really go up the same height? Is that physically possible, what I drew? This problem is there just to make you guys go, what? Huh? Wait a second. Huh? Think, think, think. when it bounces back up, is it traveling the same distance? Can it go back up? If I dropped this, it's not a bouncy ball. If I dropped it, is it physically possible for it to return to its exact same height? No. So does it actually travel to 12.8s? No, it doesn't. It can't. Because this is a 12, when it goes down like this, or is it going to go back? Is this going to be a 12.8? Is that a 12.8? Oh. That's right, because you know what I should have drawn in this? This is a what? This is going, I'm going to draw little arrows. This is the bounce up, and then it reaches its height, and then it comes back down. So there are two 12.8s there. Oh, okay. Okay. I like this. I like what I have here the best, I think. That's what I would do. I wouldn't even count the 16 as part of the bounces. If somebody counted the 16, you think I'd get mad about that? No. I'd say, hey, you counted that as part of the distance traveled. I'd be happy with that. Okay? I'd be happy with that. All right. Let's put this down. Let's just go down. I'm not going to do anything else with that one. Here we go. Oh! So company offering a job with a salary of $30,000 for the first year, 5% raise each year after that. If that continues every year, find the amount of money you would earn in a 40-year career. So what kind of a problem is this in the end?
Geometric.
Yeah, geometric what? Series. This is a geometric series. This is telling me that this is going to be a problem like this. N equals 1 to 40 of some geometric series is what I know. Okay? What is the rule for this geometric sequence? 30,000 times 1.05 to the n minus 1. That's going to go right there. So in your 40-year span with this company, 30 times 1. Oh, why did I just do that? Hit the wrong button. X, 1, 2, 40. 40 years at a job. It's a long time. Okay, so I got that the sum of 40 years is you guys get the same thing? Yeah? No, yes? I think that's right. Okay. So yeah, $3.6 million. Okay. All right. Did you guys have more on this? I didn't think so. So guess what? I just have some practice problems on the board. I don't have anything else to hand to you. We're just going to do some problems off the board. So I'm going to open this other one I have up. Okay. Whoa. All right, here we go. Let's try this one. And then what I'll do is I will post these answers on, I'll post this online, have the answers on it. That way you can look over if you want to, but I just didn't print them off as a hard copy. So once a week, Mrs. Baker makes sugar cookies for Kettering Hospital. The first week she makes the recipe, she makes 2 dozen cookies. Each week after that, she increases the amount of cookies baked by 50%. How much sugar cookies does she make in the 5th week? How many sugar cookies does she make over half a year? And if she works at the hospital for 35 years and never takes any time off, how many cookies will she have made in total? All right? So try this problemo out. I'm going to go in here and fix this. There we go. working on that. Dun, 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 do, 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 do. Do, do, do. Dun, 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 sugar cube. Is this arithmetic or geometric? Just make sure we all have. So what's the rule going to be? Okay, so you're gonna put it in as actual cookies, not dozens. Okay, and that's fine. So he changed 2 dozen to 24 times 1.5 raised to the n minus 1. Okay, and then I'm gonna find a sub 5. So how many cookies? 121, you said? 0.5? Okay, that's cool. I'm cool with that. 21.5. All right. Proxima, have you done part B yet? Tell me what you found.
What, the answer?
No, not the answer yet. Like, tell me what in your head you said, oh, I have to find blah,
I have to find how you took half a year.
which is
26.
26. So you found something like this, right? But you used probably this method instead.
Oh, I didn't do sigma. I thought you were supposed to do like and 26.
Well, it says how many sugar cookies does she make over half a year? So wouldn't that be the total amount in a half year? That's how I read that. Okay. So this would be a sum of all 26 weeks. So now we're going to have n equals 1 to 26 of that thing. Let's just, if we have to round to the nearest tenth, I'm completely fine with that. Nearest tenth of a cookie. That's a lot of cookies. What do we got? I got a number in front of me.
1,818,036.
0.1. Wow. in just half a year. Okay. Cheryl Cookie's got nothing on Miss Baker. A lot of cookies. Then it says she does this for 35 years. Continues the pattern for 35 years. This woman's insane. What is this number going to be for 35 years?
1,820.
Say it. 1820?
Yeah.
My calculator said it was too big to calculate.
Yeah, that was on the fine.
For this number here.
Yeah.
Yeah. Crazy. Yeah, this is like crazy amount.
Couldn't you just multiply?
Could you just multiply that?
Oh, no.
Because it's increasing all the time, right? Yeah, it's increasing all the time. It's insane. Okay. All right. You're not gonna get a number to that. Do it by hand now. Just kidding. All right. Let's go to the next problem. Mr. Mold is a sadistic teacher who likes writing lots of exam questions. Usually starts out the semester with only 10 questions on the first exam, but for each subsequent exam, he writes 1.5 as many questions as were in the previous exam. Since there's no such thing as half a question, and Mr. Mold likes writing questions, round your answers up to the next integer. How many questions are on the second exam of the semester? How many questions are on the third exam? How many questions are on the fifth? And if Mr. Mold wrote 20 exams in a semester, how many total exam questions would they have all together? Nobody wants Mr. Mold. Nobody would want Mr. Mold. By the way, arithmetic or geometric? Geometric. Just write the rule. Why not? A sub n equals times 1.5 to the n minus 1. Great. Okay. Second exam, how many questions? 15. All right. And then it doesn't matter what the tense is, we're always going to round up if it's not a whole number. So how many questions on the third exam of the semester? 23. How many are on the fifth exam of the semester?
51.
How many? 51?
Yes.
Okay, now here, of course, is n equals 1 to 20 of that rule. So how many total questions did they do? Yeah, Owen.
I got 66,485.
66,000.
485.
Mr. Mold is very sadistic. Rude. Okay. There's no teacher like that, hopefully. Well, Mr. Mitter's kind of like that, but I'm just kidding. All right. These are just for fun. Here we go. Try this one. Yinan took a job decorating houses with Christmas lights. He charges 25 cents for the first strand, 60 cents for the second strand, 95 cents for the third strand, for as many strands as the customer wants. Alex just hired Yinan to put 88 strands of lights on his house for the season. Help Yinan show a formula to Alex for calculating the cost for the final strand of lights. And what is Alex's total bill? Oh, yeah. La, 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 la. This, this, this. And what is going on? Okay, let's click on now, work with me here. Okay, well, close that. So, you can give me the rule, formula, rule. 0.25
Plus
and minus 1,
1.
0.35. Okay, boom. And then the final strand of lights, A sub 88. What is that final strand of lights going to cost Alex to put on his house? Just this final strand.
$30.70.
70? $30.70. You guys agree with that? Yes, no, maybe? Yeah, okay. So there that is. So what's Alex's total bill? That's going to be N equals 1 to 88 of this. What's the total bill going to be? 50 cents? 80 cents. 1361.80? Yeah. Okay, there you go. Perfect. Perfect, perfect, perfect. So far, so good? Oh, La 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 la. Okay. So, run rule for the height of the basketball on the nth bounce. So is the 82 part of this? Is it going to be included in my rule, like the actual rule itself? It goes back to that last question, right? So are we counting the initial drop as a bounce? Is the question. And we can, if you want to, we can do it that way. So here we go. If I do that, it would be 82
Yeah, that's not a bad idea.
times what? What's that? 0.85 to the n minus 1. Okay. So find the height of the ball on the 6th bounce. What do you guys think? If I use this, what do I get?
36.
Just round to the nearest 10. 36.4 feet. Okay. If you didn't make this 82, if you said that initial drop's not a bounce, and you said the first bounce height was whatever, you could say this. Did anybody do it that way instead? I'm just curious. Some of you did. Okay, so what would it be if you do it so that initial bounce is not 82? Riley, did you have your hand up?
Yeah.
What'd you have?
I had 30.950.
What did you have though? Did you have a different rule then?
Oh yeah, I had ace of n equals 69.7.
69.7. And then you had the same thing after that, right?
Yeah.
Okay.
I have a question.
Yeah.
If you wanted to do it like that, couldn't you just drop the -1 on the end? So you just
You mean on this?
yeah.
Yeah,
So it would
you
just
could.
be
Yes. Okay. So this would work, and then you could do a sub 6, and of course a sub 6 would just be different, right? A sub 6 would be. What'd you get this time?
30.950.
30 point.
9.
Yeah.
9 feet, okay. Okay, now, what Grace is asking is, couldn't you just change this and make this an n? And the answer is, yes, you could. You could treat this, if you're thinking like this, you could treat this not like the first term, but the 0 term, the previous term to that. And if you're going to do that, then you have to make this just a plain old n. So there's multiple ways of thinking of that. All right, multiple ways. Last one. Okay, now I don't know if you can see this or not, so let's read this. It says, a square has 8-inch sides. A new square is formed by connecting the midpoints of the sides of the original square, and then 2 of the corner triangles are shaded. Okay? Write a rule for the area of the shaded region after n squares are formed inside the original square. What is the area of the shaded region when there are 4 squares inside the original square? And explain your reasoning. Okay, so square has 8-inch sides. A new square is formed by connecting the midpoints of the sides of the original square, and then 2 of the corner triangles are shaded. Okay, I'm not sure. Let me see something here real fast. I need to. Oh boy. Where's the one I just closed? I don't know if it's this one. Whoops. Bring that over here. That is not the one. Because I can't see the shading very well in there. Can you guys? I'm just trying to see. I just had one open in here that had a better version of that. Maybe it was this one. Files in use. It is. That's not it. Maybe this one. No, it's not that one. I know it's not that one. Maybe it is that one. Yeah. I don't know why when I put it over here, you can't see it as well. Why is that? So just so you know, you can see this one shaded, can't you? Can you tell that one's shaded? For some reason, it doesn't. It shows the bottom one. So in this one, it's this and this are shaded. Okay. On the next one, it's this, 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 and this one are shaded. So they're like across from each other. The ones that are shaded always are. So here, then it's this one, this one, this one, this one, this one, and this one are shaded. On the left, this one, it's this one, 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 and this one are shaded. I don't know why it doesn't show up better than that. I think part of it is my smart board is not good at that, showing stuff like that. Let's change. That's no better. Nor is that. Nor is that. That's worse. That, I don't know why it doesn't want to show. So you guys are trying this. Well, that's even, man, that's horrendous. Okay, well. So write a rule for the area of the shaded region after n squares are formed inside the original square. Ooh, that's a good question. Just curious. So this is, does everybody understand that this is the first term right here? I've given you the pictures of the 4 terms. Right? So what do I need to do to this first one here? What should I do?
Is it like, for example, like triangles like same size as the square in the middle?
Or what do you mean they're the same size? I mean the same area?
Like the shaded ones are like the same area.
So you're saying that these 2 have the same area as this, or all 4 of these have the area of that? I'm not sure which one you're saying. Say that? Just the 2. Okay, well, let me ask you this. So I told you that the original dimension of this was what? 8 by 8. So this originally was 8 by 8. Okay, so let's think about this. And I said that these were the midpoints, right? So all of these would be the same length. So what would let's just look at this right triangle here. What would be the length of the legs? 4, right? It'd each be 4. And then this one up here, I could draw it like this, and that would be 4, and that would be 4. Aren't these together a square as well? Those 2 shaded ones? So what's the area of the shaded region here? Total. 16. So for the first one here, the shaded area is 16. Okay? Now, for the second one, I just want to know the new amount, right? What do I want to do here? I got to find out what this new amount is in here. In order to do that, I'd have to know what? Yeah, I'd have to know these lengths here, wouldn't I? Well, guess what those lengths are? I'm just going to tell you. They're 4 radical 2. They're 4 radical 2. 4 radical 2. 4 radical 2. 4 radical 2. So then in here, when you do that, let's just go ahead and draw that. And you connect this and this and this and this, and you go bloop, 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 bloop. If this was 4 radical 2, what's this little piece going to be? 2. It's just, what's 4 radical 2 divided by 2? 2. So this would be 2 radical 2, and this would be 2 radical 2. And over here, this would be 2 radical 2, and this would be 2 radical 2. All right? All right, so guess what? I'm going to post that. You can keep working that on your own tonight if you want to. Tomorrow, we're having a test. I will tell you now, the test, the first part of the test is a lot like what I gave you the other day. Where's it at? The sheet that looked like this in the front, where you had 3 summations on the top. This was pink, right? It's going to be like that on the front. The front's almost identical to that style of question. And then on the back, you'll have a few word problems. Okay? There you go.
Can I get the pink paper?
You don't have that one? That one was,
Should I?
did you get this one?
No.
Maybe we did that one on Thursday. I thought we did that one on Tuesday. Maybe not. Here you go. You can take it.
Should I take my test tomorrow?
Let's have you do it Thursday. Okay, you're gonna be here Thursday, right?
I will.
We'll have you just do it Thursday instead. Okay, and then when they're doing it tomorrow, maybe we can like, if you need to come up and get any help, we can help you out. Okay.
Thank you.
I will be here on Thursday. I'm going to Maine, so I'm leaving Thursday morning.
As if you don't have enough time off already. All right, well, you'll have to just do the work then somehow. Let's make it up. Or just, it's all about special right triangles, stuff like that. You have to understand that when you come back.
The word problems aren't gonna be like that and. the
No,
ball
this
right?
one here would not be on there.
What about the ball one?
The ball one, if it's a ball one, I would stipulate the first bounce, like the drop doesn't count as a bounce. I would stipulate if I had that on there.
So like there could be multiple different answers if it was
No.
on there?
No.
No?
If I gave you a ball problem, I would say do not count the original drop height as a bounce,
Okay.
which means that you would have to find the height of the first bounce and count that as your first turn,
Mhm.
like he did when he did the problem. So I would force everybody to do it the same way. I'm not going to leave one where it's open-ended like that.
Okay.
They're all going to be, you should be able to figure out, I have to do this. Everyone should do the same thing. Okay?
Okay. Thank you.
Yep.